Can you hear me? Can you hear me? Can you hear me? I don't know whether you can hear me. Hi Corky. Hi Jay. Hi Numatech Prototypes. Hi Gordon. Hi Jason. Hi BP. Okay, so you can hear. Excellent. I have another device to set up, so I'll do that right now. Sorry about yesterday. I'm really sorry. Basically, I got my dates confused. But anyway, let me see if I can sort that other device out here now. Because I'm actually going to be presenting off another laptop. I'm going to do it kind of like the kind of previous style I did, and hopefully with this Logitech camera that I'm looking at you on now. And I can then point at the screen at the same time. So now, in this presentation, I'm going to be saying some things that I've wanted to say for a long time. However, a lot of needed to be said beforehand, and I would have liked to have more time to put the presentation together, but you're going to get what you get. And I think it's good to get these things out there so that people can think on them and think whether they've seen anything similar, or can make counter arguments and those kind of things. And so I'm interested in like how people see what I'm saying today, whether it has any relevance, and those kind of things. Okay, so what am I going to plug in over there? I can plug it in up there, can I? Okay, give me a second. Okay, that'll work. Okay, so yikes. I think that's everything I wanted. I need to move the camera, so I'm going to have to switch on to a different camera in a second. Okay, so let me get the presentation up. How's everyone been? Say where you're from. Okay, maybe I can do it like this. Oh, I need the camera on the tripod. Okay, I'm going to have to put the camera on the tripod. Hi John, great to see you here, fantastic. Oh no, I know you have to get to the lab. Sad, but true. But you can always watch it later, John. Anyway, there's a couple of things in there from your work, and I'd be interested if you have any opinion on those, what I have to say about them today. Okay, so yep, this is live. Okay, so right, best to start at the beginning. I'll get my eyes on. Hi, David. Hi, Glass Chappy. You're on planet Earth. Yeah, that's we're both on the same place, I think. Just at least that's physically. Okay, right. I'm going to switch cameras now, because the camera that you've just been looking at, I'm going to try and get it to look at the presentation. So we'll see if that works. This could be interesting. Okay. Feels like I've been collecting this stuff for the past couple of years to do some. Yeah, right. Well, I think with what's going on with Vega, and I think the Baroness is going to be in a position to do some interesting work, and I think this will work. I think I'm going to show you what I have here. It's not ideal. Okay, right. Maybe I can zoom in there a little. This will make sense when you can see. So what I will do actually is I'll probably either do a video of the slides and give you the PDF of the slides. The reason I say do the video of the slides is because I'll have the animation builds in there. PDFs don't capture those. and I might upload that separately and include it in the remoteview.icu blog when I do some further write-up. Okay. I'm getting my orientation a little bit squiffy here. Okay, is that going to work? It might work. So, sorry it's not perfect, but you get what you get. Right, okay, alright. There's a bit of zoom in there. Actually, then reposition it down there. Yeah, okay. Don't know why that's a bit of parallax. Let's see if we can fix that. Right, family duty, so really big sorry about yesterday. That's normally I do things very late at night, and I added 2 days on from expecting it to be past midnight, and it wasn't past midnight. It was actually on the day before. Oh dear, this is going to work. I hope. That's a big fail. Oh dear. I could probably give you the visual of what I'm trying to do here. That would probably be a little bit more interesting for you and suffer through my grunts and groans. Okay, that might work. He says, deluding himself. Okay, and if we zoom into that a bit, it's going to make more sense now. You'll probably work out what I've been making a noise about. Okay. So, triangles and spirals. This is the frame. I can put my ugly mugshot there, but I'm not sure you're interested in it. So I'm just going to talk over it. Okay, so these will actually be higher quality. Can everyone see that, by the way? That would be useful if I could actually know if you could see it. Okay, so what you're looking at there is a composite slide that I made of a number of interesting things that I've seen over the years. And the first one is this. Actually, the first one was this spiral on the nickel foil from Suhas Ralkar's Echo reactor, and the foil was used to produce as part of the structure of the reactor, and he produced this foil. And this is actually a nickel spiral on the nickel foil, and this is a nickel structure as well, but it's actually just the spiral form, this very Schauberger-like spiral, and it's not necessarily clear to you, but this is very much in the foreground, and this is in the background. So this is a spiral that actually has a three-dimensional plane in this way. It's not two-dimensional. Now this one, again, this is on what I call the eastern plateau of the Vega Valley sample. So maybe if I get the Vega Valley sample in shot, maybe I can do that. We're talking about an area around here on this sample. So it's just about there, that spiral. And they're very similar, although this one obviously is in 2 dimensions. And so it hasn't got that towards the camera dimension. Now, this is a fractured piece of mild steel. I'm going to check it's mild steel, so I don't make a faux pas. Faux pas, rather. Faux pas? What's a faux pas? Oh no, a faux pas. What's a faux pas? Okay, all right. So I've got a strong neodymium magnet here. So this is the sample here. Maybe we can get it focused. Is it going to focus? Yeah. Okay, and you see these triangle structures that are on the split plane, and some of them are distorted, but it is magnetic. So we have a piece of mild steel here, and then we have aluminium here, And this is the quartz liner of one of the Lion reactors that went this kind of brown look. And it has these sharp triangles. So we got sharp triangles in the Hutchison sample, which is iron. We have sharp samples in the formerly, and probably still likely mostly, fused quartz. And we have soft triangles in the aluminium sample. So I'm going to go on. So this is the 21st of February, and that's my reflection there you're seeing in the mugshot. And some of these things, like this and this in the Lion, and this in the Hutchison, and this in the Hutchison, helped me come up with something, I believe, which came to me actually somewhere between the state of sleep and awake in January 2018. And basically, I have these moments, I think I've spoken about it on the private section of remoteview.icu, where I kind of get, like my blood pressure goes up, I get hot, my mind's racing a bit. It's in the middle of the night, sort of in a semi-conscious state, and I don't know. You might call it downloads or whatever, but this is the thing. It's not really, it's not really exposing that well, is it? So let me see if I can deal with the exposure. Let me deal with the exposure there, because that's just not working for anyone, is it? Oh dear, is that going to work? Oh dear, I'm sorry about that. I don't know why that's not helpful at all, is it? And it's just changed its exposure. Okay, that's completely useless. Okay, give me a sec. Oh dear. Okay, that's not useful, is it? Why has it done that? Oh dear. Oh dear. Maybe I can change the image parameters on that. What an epic fail. Bring the exposure down. Maybe it'll... No, it's adjusting. Oh, this is useless. Can I invert it? Oh dear. Terrible. I'm sorry. I'm fighting a camera that's trying to adjust. Yeah, I can put the camera in a little nearer. I did consider that. There we go. So, oh god, come on. Seriously? How close does it have to be? I'm now on the keyboard. It's not helpful. Okay, so right. Oh dear. Come on. Is that going to work? Hey, I think we got something working. You can definitely tell this is live. Right. Hello, Bernard. Hello, Taran. Okay, so this is the structure that came to me. Some might call it remote view. Some might call it a download, whatever. But bearing in mind, I had seen this structure and this structure and this structure and this structure and this structure, and I had an idea that several other forms that I was seeing, particularly on the Lion reactor, can only be explained by something that looked like this, then it's not surprising. But what you're looking at here is half of a soliton. And you have effectively counter-rotate. If you take a slice through the soliton, you have counter-rotating vortices. But in fact, it's the same vortex going round, except it's going round in a spiral like this. And this causes its own vortex in this lower part of the structure. And if there's anything coming in here, some of it may go around, and it kind of almost goes in an infinite loop. And what this does is it creates a self-focusing point at the center here, both in as the point of the spiral and also the point of the material that goes around the soliton. Now, normal sort of Lord Kelvin solitons don't have this spiraling going around like this. They just go around like this. So you don't necessarily get this vortex. However, there is, if you imagine this is going through a medium, whether it be gas or liquid or the ether, whatever it is in the medium is being moved fast here and then gets pulled in here and gets shifted out there. So you have a net vector going down here, and this leads the soliton to go forward in this direction. And at some point I'm going to I will revisit the Suhas Ralkar ultrasonic tank where I showed the sprites and show the structures in there that follow this format, and also with smoke rings, and project that forward to this moving through the ether. But anyway, the point is there's two kinds of triangles here. There is the triangle that is created by this, and there is the triangle that's created by this, and they are actually different. And I think I've demonstrated both components of this. In fact, both components of this led me to probably come up with this concept. But I think the key point is that you have a spinning concentrated focal point at a junction between three different spiraling things. If you take any section through this soliton, you will end up with this focal point. Now, if this is spinning really fast, you might imagine that the focal point would shift up and actually be in a different position from the center plane to this. And if the ring was larger and that was shifted up, you would have these triangles that were moving further and further apart. So anyway, the point being is that this here is a vortex. So it's you've got your kind of vortex going around here, but this is really is a vortex, and this, I believe, is very significant. Now, whenever you come up with any idea, it's almost certain that someone has thought of it first, and it was no surprise to me that after I published that at Sochi in 2018, someone informed me about the work of, and that's just not in focus. This is not working out for me right now. I'm going to try and fix focus that. Is that right? Okay, that might be better for you. Sorry. But like I say, the slides will be available. This is already available, the slide anyway. I'll already publish this slide. So essentially, this was in a patent in 1973 by Paul Collock, and he was trying to develop technology for fusion. And it explains here how you have toroidal and poloidal movement, and that creates a sheath, and the sheath has a certain dimension, and there is a strong field that prevents the material coming in, and if the material comes in with higher pressure, it increases the intensity of the field, and so forth. But that's how you get a self-organized, what he calls a plasmac. Anyway, so it's a similar structure, but it's kind of very even this way, and it doesn't, for me, it does have this focusing in the center, but it isn't something for me that looks like it would travel in a particular direction. So for me, it's not exactly the same thing. However, it does have spin. It has spin around its outside sheath, spin in the center, toroidal and poloidal aspects. This is this zone which is, you know, it kind of resists being compressed, and we've observed these kind of structures, and this is inside the supernova reactor inside, and this may be material that was transported on the sheath or in the actual plasmoid or whatever. But now I want to talk about the work of Bogdanovich at the National Research Nuclear University, Moscow Engineering Physics Institute, and this was published on the 15th of May 2019. They actually submitted it on June the 29th, 2018. But anyway, I will go to the paper because there's a couple of things that I want to read from it. But in brief, they did these plasma flow water flow plasma discharges. So you have water coming down, and you had discharges through that onto a metal plate, and you get a range of different plasmoids being formed. And what they observed were these kind of toroidal plasmoids moving around on the surface of the metal plate 2 days after the end of the experiment, glowing. Okay? It says the toroidals are inhomogeneous along the azimuth as evidenced by the movement of the darkened sector from left to right, and vice versa, which most likely corresponds to the rotation of the toroid around its own axis. So I imagine the axis is going through the plane there, perpendicular to the screen, and that it's going around like that. But notice this little tail that sticks out to the side. Now, what he says is if you have a stream of particles, they say presumably electrons, which causes air to glow, is emitted from the surface. After 10 to 20 seconds, this stream is formed into a set of several rings, 5 or 6, of the same diameter, which rotate around both their own and common axis parallel to the plane. So they actually produce these crystal-like structures. So you've got kind of these, but in a crystal-like structure. And then another thing that they observed was the fact that whilst you had this plasmoid here, and you can imagine that this here is a bit like the torus that I am suggesting up here, which it probably won't show properly. But anyway, you have this torus here with this glow of the ball, but they're saying that there was a separation of a plasmoid part from its body. Okay, so is this the body and this is the plasmoid and so on? But I want to read what he says. And effectively, this is actually a barrier. And so part of this has actually gone through the solid material and onto the other side. So let me go to the paper here, hopefully. Not this one. This one. And I'll read from it, and sorry if the contrast gets all messed up. I will find a better solution next time. So the analysis of the obtained data shows the presence of luminous objects moving along the surface. The shape of the objects is presumably toroidal, and the axis of the toroid is parallel to the surface. There are reasons to consider them rotating relative to this axis. The toroids are, and that's the bit I've already told you, they have a size of approximately 50 micrometers and a speed of more than 10 micrometers per second. The time of their stay in the field of view of the microscope with the video camera is a few tens of seconds. The plasmoid emission color is green, which may indicate an air temperature that corresponds to wavelength of 5100 or to 5500 angstroms. The dark sectors are not visible on individual objects of this type. Okay, so I'm just going to read you a couple of things from here because it'll speak to things that I'm going to talk about later. A stream of particles, so that's the one where it's talking about this collective structure here. Okay, a glowing object in the form of an ellipsoid which rotates around its axis hangs above the surface and in its lower part, which is closest to the surface, forms a prominence, elongated towards the surface. So he's actually talking about this. So you actually have this prominence coming out of here, which then detaches and passes through the surface. Of particular interest is the presence on the other side of the surface into which the budding part of the ellipsoid is drawn in. A spherical object, this one here, making a movement in space, at first glance not correlated with the movement of the ellipsoid, but within the video field view, the dimensions of the ellipsoid and spherical object are several 5 to 6 millimeters, several millimeters maybe, 5 to 6. The duration of the observation of the process is about 1 minute. The glowing color is blue. So it's actually a significant amount of time. But what this is showing is that this is able to travel through, and in this case, it's a dielectric surface, and come out the other side. So that's interesting itself. Now, the part that is really interesting to me about this paper, because I had come to the similar conclusions in 2000, the beginning of 2018, but it's kind of spelling it out here. The key question is still the occurrence of magnetic monopoles or objects with similar properties. So they're not saying it's necessarily a magnetic monopole, but it basically has the properties of something that is masquerading as a magnetic monopole in the discharge zone. One explanation for this process can be the recording of the prints that indicate the presence of the object belonging to this type of physical objects in the form and properties. In particular, their penetration through the double envelopes of film projection and print type in the zone nearest to the discharge on X-ray film. In accordance with modern concepts, electrons can form Cooper pairs in the field of a monopole and rotate tending towards it, but at the same time losing energy in the zone near it. A halo of electrons and atoms of ionized air can be formed around the monopole. The total magnetic field, together with the plume field, can be interpreted as a dipole field, in the outer zone of which electrons can exist stably, including those in the quantum state at ultra-low temperature, and form structures identical to those shown in Figure 7. So Figure 7 is this one. Okay? Rotation around common axis resembles the dynamics of electrons in Earth's magnetic field gradient drift. Analysis of the obtained results clearly indicates such properties of the observed objects and phenomena as the presence of superfluidity, ability to form objects with clearly fixed dimensions, and rotation of objects as a whole and in separate parts. It is the magnetic monopoles or dions, which are accompanied by the plume of Cooper pairs, can create magnetic fields of dipole configuration, in which the electrons of the outer shell form electronic rings of the same size due to the quantum nature of the magnetic flux. The results of the penetration of the plasmoid through the dielectric barrier can be explained by the fact that the electronic plume follows the monopole, or more precisely, by a cluster that contains ions, electrons, and ions, which presumably penetrates through this barrier. Okay, so that in context. Does anyone have any questions right now? Anyone have any questions? Okay, so now I am going to go back to the presentation. And here we are. And so the next one I want to draw your attention to is the type of monopole that Bogdanovich and the team at the National Research Nuclear University in Moscow, Russia, think is a good candidate to explain the observations that they've explained. And that is the Dirac monopole derivation as proposed by R.P. Wisniewski in 2008. Now, I've translated this before. You can go and look at the video where I discuss this down here. I think it was the 4th video out of 6. There's two more to be published, but it was the 4th out of 6, and you can go and see that there. And the link to the translated version, roughly translated version of this paper is here, and we're going to have a look at that in a minute. But what I want to draw your attention to is that they have the magnetic core here, okay? And they have this conical structure going down to the magnetic core. And what this conical structure is the vortex through which electrons are cohered into Cooper pairs around this magnetic core. Now note that they have expanded out this magnetic core here into this ring. And what you have here is Cooper pairs, and this is basically it's a condensate, but I understand it to be restricted in dimension, overall dimension here, by the electron degeneracy pressure. Okay, so it can only get to a certain minimum dimension around its common axis, but it is extremely small, this thing here. Okay, but it will throw out electrons that don't quite match up or whatever, or that becomes unstable in some way. So you have this vortex structure going in and the core. And what would this look like? Well, it is the understanding of, well, let's just look at a couple of things from the Wisniewski paper. So here it is. Now, he is talking about this spiraling towards the magnetic core. You can't necessarily read that, but it says magnetic core. And he talks here about a logarithmic spiral going in. And in fact, when you have two opposite. Now, if you remember the Vega experiment, where we had a coil of wire, we had a situation where when one plasmoid was on one side, it ended up by having another plasmoid or macro ball lightning form directly opposite. So it's almost like it went round, and when it got to a certain point, then another one could grow directly opposite. So is that something that's relative to what's going on here? I don't know, but it's just by the by. And then you have two that spiral in on this, he says, logarithmic path. And then this is the structure that he's talking about. Now, if I go back to the presentation here. Now, do we have any evidence that it is actually really a monopole? Well, I've discussed this work by Leonid Roitskev, and he found that firstly, he created ball lightning outside of his exploding wire chamber. What you have here is a mirror. You have the electrodes going into the chamber, which is actually below and out of shot, okay? And they would say, for instance, they would have a tungsten foil in there in water, and they would blow it up. And they would get these balls of light forming above the reactor. But in about 0.7 of a meter away, so if you had the reactor here, 0.7 meter that way and 0.7 of a meter that way, they had a magnet, and on the back side of a piece of 57 iron foil. And then they had another one with the magnet, but the opposite pole on the back of a piece of 57 iron foil. And what they found was, set against a control that didn't have a magnet and was nowhere near the reactor, that the one that had the north had the magnetic fine. Basically, iron 57 is a nuclear magnetic resonant nuclide isotope. And so it has this particular property. And where the north was on the back of a piece of iron, it went one way. And when the south was on the back of the piece of iron, it went the other way. So what it looked like is that the exploding wire was emitting particles of charge, magnetic charge, i.e. magnetic monopoles. And he later, these are actually from the work of Bogdanovich. And he later did this using an electron beam into conversion targets through a magnet, and he got these structures, which I've just colored to correspond to the fact that one is going in here and one is going in here. Now, if you imagine this structure here, you've actually got something going in at the bottom, which you could imagine is going in a spiral, and then you've got them coming out in a spray, but there's also a deviation somewhat. So what I'm saying here is that some of the material comes in here, and it goes out like that, and there's a slight deviation, okay, but essentially there's a flow into the environment over here and a flux in here. But if this is moving through a medium, then it would be kind of tractoring through the medium like that, so it can move and eat into things. Okay, so this is what basically I'm saying is that Roitskev demonstrated practically that exploding wire in water led to the production of monopoles, okay, which changed the NMR moment of the nucleus of iron 57. Now, so that is one thing. Now, about the spin, this is from a presentation by Zatelepin and Baranov, again at the 25th Sochi Cold Nuclear Transmutation and Ball Lightning in 2018, and I've shared this on our the MFMP YouTube channel, and also from the description there you can get access to the paper, the actual slides, and he's showing this ball lightning from some sort of record, and this laser-induced compressed plasma. So this is kind of like a ball of fire but created in the laboratory. And what he's arguing is that the modification of gravity or the weight of the ball lightning is due to its spin. And he's saying that the spin is really extremely fast. Here it's saying 100,000 kilometers per second, and here it's saying 40,000 kilometers a second. And why he's saying that is because you've got redshift and blue shift. So I guess it's spinning round this way. So you've got redshift there because the material that's emitting the light is traveling away from the camera, and here it's traveling towards the camera. So you've got blue shift this side and red shift that side. Blue shift this side, red shift that side. So this is natural ball lightning, and this is technologically produced equivalent ball or fire. Okay, so we have spin. So an extremely fast spin. So he's given another couple of examples here of this is technologically produced. This may be technologically produced. Okay. Now, what I've talked about is you know, this focusing of electrons to a magnetic core. The magnetic core having not a zero dimensions. It does have a dimension due to the electron degeneracy pressure. And that it produces monopoles, and you can imagine, I call this the yin, and so this is pulling stuff in, is the yang pushing stuff out, or it's kind of like the antiparticle of it. That's you know, something that it would be interesting if you thought about. But this triangular section here, I believe, is something like this, which we observed on the crust of the Lion reactor. And you can notice that it isn't actually a perfect sort of plethora that you would pluck a guitar with. It actually is slightly off-center. You've got a curve here and a straight section here. And the interesting thing is that I believe that this material that crashed through the surface here, and you can see a video of this being taken out on the SEM when it occurred, I'm saying is the material that flows through the core of this loop. Now, if you go and look at the ICCF 22 presentation of and I'll remember his name in a minute, but he calculated that the pressure inside this torus, inside the center of this with the ions, was equivalent to that in a pulsar, which is a type of neutron star. So vastly more, I think something like 5 orders of magnitude more pressure than you have in our own sun. So there's plenty of opportunity in this. So there's a ring and a spot. I've been talking about a ring and a spot. I believe that certain elements are predisposed to be forming in the ring, and so other ones are more likely in the spot, or other things can occur in the spot, like nucleon disintegration and so forth. But these whole things, as we have shown here, can form into clusters, and these clusters, according to the work of S.V. Adamenko and the work of Matsumoto, they can self-compress, and then that can also lead to effectively nova-type reactions. And I will get much more as we move forward into this kind of life cycle of exotic vacuum objects and structures of this type. Anyway, so this was in the Soliton patent that was applied for in 1992, and he saw these same triangular structures here. And again, what I'm saying is that whatever goes into these this circle here, it can be stripped down to alpha particles, and it's not a black hole, it's a black donut, although that is that focal point as well. And where there was no calcium there, which, you know, there was no calcium here, no calcium here, but on the actual piece that goes through, this piece here, it was made of carbon and calcium, whereas the rest of the crust here is copper and oxygen, okay? So the carbon may have come from the core of the reactor, where we had diamonds, if you remember, in the Lion reactor. And we know the diamonds were eaten away, and we know that the exotic vacuum objects traveled from the core of the reactor all the way to at least outside of the quartz. And so it's not surprising that then this would contain carbon, but carbon is tri-alpha. Calcium is actually dec-alpha. So this is 10 alpha particles mixed basically, and oxygen is also the other component here, and oxygen is quad alpha. So these are alpha conjugate nuclei. Anyway, so that is material I believe has come out of this ring structure. Okay. Now, there's also these bead chains, and you can imagine these bead chains are little ball lightnings, and they have an attractive and a repulsive field. So it's like. It doesn't. As it gets closer together, it will find some sort of balance between it. And we observe the same things in the Lion reactor as well. Why I'm showing you these is that they're not necessarily the same structures that we're talking about today, but they're all part of the same family. So this was in the Soliton patent applied for in 1992. Here we go. And this is on one of the Lion reactors. And these are counter-rotating parts of the soliton. So the soliton is going through the surface. Here it's going through the surface. It's actually eating from the inside of the reactor out. So what I'm saying here is that part of the actual structure that's making this is able to pass through the material and come back into it without kind of like any restriction to the fact that this is actually a dielectric, which is something that obviously Bogdanovich has caught on video. Okay, so now back to the subject of the day, which are triangles and spirals. So the first one was this one, our Schauberger spiral from the Suhas-Ralkar nickel foil. Okay, so I am going to show you, I just need to switch cameras just to make sure I don't do something wrong. Somewhere here. Hold on. Give me a second. Taking a long time to shut something. Okay, so I have it here. Okay, so what I want to talk about is it going to work? Let's see if we can go back there. Is the hyperbolic spiral. And you're probably going, oh, Bob, you're just talking hyperbole. No, I'm talking hyperbolic spiral. And so this is something that comes out from the tangent over here and goes in and reduces down and reduces down here. So this is our hyperbolic spiral. Here we have another example of a hyperbolic spiral. Now, this isn't the best description of them. This is quite a good description. And essentially, a hyperbolic conical spiral is one that starts like on the base of this cone, and it's tracing as it goes round its radius. It's going and following up the cone, and so is the logarithmic spiral of Wisniewski, can it be described in this way? I don't know. But what I'm saying is that the cone that you have here actually isn't this kind of dimension with the base and the height, whatever the ratio is. I'm saying that the cone is the ratio that we are observing in these triangles, in these triangles, in these triangles. And that as it's going round and producing this hyperbolic spiral, which you are viewing here from the top, okay, it has a limit where in the center near the magnetic core, the center in the magnetic core here, the limit would be the electron degeneracy pressure of the electrons as they get down there. So it doesn't have zero dimension. It always has a dimension, that magnetic core. But I'm saying that the magnetic core vortex, and this is where I'm at, is actually caused by this structure causing this spiraling in and this focusing of material at this point, which may shift depending on aspects that are going on here. Okay, so this may shift. In fact, it may shift so much that it spits something out and fires it out. So it collects a load of material and it goes pew, pew, like that. Okay, so I'll talk about that another time with respect to Shishkin's studies. And if you want to get ahead of me, and you can go and read some of Shishkin's work. Anyway, so that's this material coming here. So I'm saying this cone here, on which the hyperbolic conical spiral is being structured, is based on the triangles that you have here, here, here. Okay, these triangle structures, and that they lead to the vortex-like Schauberger type spirals that you see here. Okay, so what I'm going to do is I'm just going to overlay that hyperbolic spiral on there. So you can see that the center point somewhere here. Now, actually in this case, it comes down and actually it changes in third dimension that way. Is this relevant? I don't know, but I'm just saying this is what you see. Now, in terms of Hutchison, this was the one that really first struck me. This shape over here. Okay, it's I don't know whether Gordon is the outside or the inside, but anyway. So this is the one that struck me first, because the other holes, mostly, actually, not entirely, but mostly, were coming from the outside. This is a piece of aluminium, a large piece of aluminium, actually, that was affected by the Hutchison effect. And we've got another one, the other half of it down here, so it's cut in half. So we have this triangle structure that's kind of like in the middle of the aluminium. Now, Ken Shoulders said that the exotic vacuum objects can go into some metal and then they can be excited and start growing. And I believe that this is disrupted material. And this disrupted material, maybe it started down here and it was a very small triangle and it grew 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 as it progressed in this direction. And this is the cone that you see. And maybe the actual vortex is somewhere here, but you just can't see it because it's not something we have instruments to test for. And maybe there's just a shadow of the vortex and maybe it could be re-excited somehow. But what confused me for a very, very long time is I thought potentially that this bit on the edge here was actually one of these, but it didn't follow this conical structure that I'd seen before in other technologies. Why was this odd? Okay, well, it was a long time until I actually realized what was going on. Now, you see this triangle here. You basically have a blown up one in a different orientation over here, okay? And maybe it shifted a little bit, so you got a bit cut out there. Now, I did think for a time, and I'll be honest with you, that if I was to try and make this, I could put a drill bit in here, and maybe I could drill these bits out. But how the hell would I drill this bit out over here? How would this occur? So I thought, no, this is a version. This one here is the same thing. This one here, there's also kind of like mottled areas on here that have a similar kind of shape. But anyway, what I'm saying is, and this one is a bulk one, but it's kind of shifted or whatever. But what I'm saying, and there's one here in the reverse aspect. But anyway, these EVOs, as I've seen on the Lion reactor, they can orient themselves and pass their fields through each other as if they don't recognize the other one being there. So the idea that these are in different orientations is not something that concerns me at all, having seen enough of this technology at play. Okay, so this is disruptive, but I still had a problem with understanding what this was. What is this? Well, I will come back to that. I'm going to focus on what is that? I mean, this is the right kind of shape as far as I would imagine. And I will come on to why it's not hard edged on that in a little while. But this was, it's got the curve here, but what's going on here? I just couldn't understand it. Anyway, so what I am saying is, in the case of quartz is high melting point. It's also, it's like an insulator when it's, not hot. And so it really does not want to give up its electrons, okay? It's piezoelectric, of course, but this is fused quartz, so it's not crystalline as you would think. But it doesn't want to give up its electrons. This is aluminium. Aluminium is the fourth most conductive element, okay? So it really has a lot of ability to give its electrons away. This is a metal too. It's a transition metal, of course. It's iron, and it is very happy to give its electrons away. Now, what you will notice is that these triangle structures in the case of the Hutchison hard metal and the quartz. So what really freaked me out about this quartz is these triangle structures were on the split plane. However, how do you get a triangle thing out of an otherwise previously amorphous piece of quartz out to the center of it? How does that disappear? And how does it happen in multiple orientations? And it was just very weird to me. It's really the first time that it really struck me, other than this one. It really struck me, and I was like, what is these triangles? And then when I see the same aspect triangles over here, I go, hold on a minute, what's going on between this? Well, what I'm telling you is my belief is that when you are having these, this cone, when you are having this coherence of electrons, the electrons are being stripped from the material, disrupting that material in fundamental ways. When that is happening, and you are getting this in aluminium, the aluminium has a low melting point, i.e. it has a low yield strength, okay? And it also has a large amount of electrons. This has large amounts of electrons, but the melting point is far, far higher than aluminium. It's also magnetic, okay? This is not magnetic, but it has a far, far higher temperature and doesn't want to give its electrons away. So what I am arguing is that depending on the magnetic, the ferromagnetic or paramagnetic state of the material and the ability of the material to hand over its electrons to the monopole, you will get a soft structure in something that's very happy to hand over its electrons and is not magnetic, and you will get a hard structure like these in something that's able to hand over its electrons or not wanting to hand over its electrons, but is a high melting point, okay? Because a melting point really is relative to the ability of the electrons to give up their bond with the lattice in this case, the metal lattice of the iron in this case, and the chemical lattice of the silicon dioxide in this case. So the lattice bonds are extremely strong in the quartz over here. The lattice bonds are strong and magnetic here. These are dielectric or whatever. And this is conductive. So the soft and hard is relative to the properties of the material that the cone of the cohering part of the material is acting upon. Now, in terms of the spirals here, again, you've got a kind of softy gloopy thing. This actual bit here is interaction. It's not perfect on this edge, and I believe that's because there's other things going on that have caused the damage to the structure after it was formed. Now, here's kind of close-up one. Now, this is the live caught on video structure here with this tail going off to the one side and this shadow over here. And it's basically a dead ringer for the form of this, okay? And what you're looking at is this center point somewhere here is where the monopole is, and it's bringing the material either up from inside the metal or down from above the surface of the metal. And of course, this was between two brass plates, and this was the lower plate. So there would be plenty of free electrons around this high temperature kind of area. And if I play that and I put the hyperbolic spiral on top of there, you can see, other than this area which is damaged, I've just done a kind of a color operation there. This is the spiral. Well, it's a Euler spiral, but anyway, you can see it's a pretty good fit on the main part of the spiral. Okay, so now I want to go to Matsumoto, and Matsumoto found a spiral also in his work. And he published this in 1993 in his paper called Experiments of One-Point Cold Fusion. And this was published in the American Nuclear Society's journal, Fusion Technology. And I've got all the details there. But he described this as whirling trace. Shows a very strange trace that was whirling around. It suggests a violent reaction, but its meaning is now uncertain. So he didn't have a understanding of what it might be, and I've just overlaid the spiral on there so you can see how it interacts. Okay. Now, coming back to this feature here that confused me for so long, and why in one respect I was reticent to talk about this feature. I did talk about this in my Sochi presentation, and at the same time as I first published this structure. And bearing in mind, this is very rough. There's no precise angles on there. It just is what came out of my head very, very quickly. It only occurred to me when I saw the two halves put back together. It's this. It's this. What is this? Well, firstly, can I just draw your attention to the fact that we have a hexagon here on the top surface, okay? Right? There's a hexagon. But this here, if I do this, it's kind of like, is it pulling the material down into the core, or is it the material coming out? Is it yin or a yang? Okay, but anyway, it's a dead ringer, and it actually goes down at an angle. If you look back at the structure here, it's cut down at an angle. This is very large, by the way. This is very large. What John was doing was not being very simple with this. Okay, so and I would imagine that if we looked at this material, it would be largely carbon. Now, there are other examples I can give you of spirals and of triangles in different materials that I've looked at, but these are ones just for examples at this point. But I don't know if you recall, if you were waiting last night on the chat, I wonder if you recall that I wasn't there. Well, anyway, I did update the blog. I'm going to switch back to the other camera now for a minute. I did update the blog, and Henk, who's one of the researchers, the experimentalists doing the Vega experiment, he ran over to his location where he's doing his experiments and had a quick look at some of his samples. And one of his samples is a similar sample to this piece of metal here. And I haven't even looked at this piece of metal. It's here. So I haven't even looked at this piece of metal under the microscope. But he had a look with the best optical tool he could. And he came back to me very excited. But before I go to that, I'm going to have a look at your expressions, comments here, and see if there's any questions you need answering here. Okay, so... Okay, sorry I missed you, Baroness. We'll talk. Okay. Okay, I don't see... If you've got a specific question you want to ask now, I'm going to come to it. Evo's where matter really matters. Yes, it does. Okay, so I'm going to go and show you these images that were basically, hi Axel, that were sent to me late last night. And I'm just showing you them because they're sent. So let me organize those. Oh. Well, before I do that, I'm going to show you something else. And it's actually an image that I shared a long time ago. And it's relevant to one of the videos that I posted on this blog. And when I write up the comments about the triangles and spirals, I will show a side-by-side sort of image of that. But essentially, I don't know if you remember, I think it was on the second video, or maybe the first video, live microscope session, we saw where a plasmoid had gone across the surface, which may be this carbon film that Matsumoto is observing. It may be carbon film. This is this area over on the western plateau, over here, this kind of area down here. Okay, is this carbon film? I don't know. Maybe it is a zinc film. Zinc's got a much lower melting point than copper and so forth. So it could be zinc. Anyway, it cut through that film, and it kind of balled up the material around the outside. Now, if you go and look at a presentation, and I'll also include this in the newsletter article when I update it. If you go and look at permittivity, not permittivity translation, Evo life cycle, there is a picture, and you could not believe it. There is a picture in there that is basically identical to those structures that we were looking at in that live session. And I didn't clock it until someone asked me for that guy called Bido. He asked me, oh, have you got the Evo life cycle paper? So I pointed him in the direction of it. And like one of the first images is essentially where plasmoid or exotic vacuum objects have traveled around the surface. He actually put a film of something on there. I can't remember what it is right now. He put the film on there. Actually, maybe I can pull it up. I'll stop talking about it and just pull the thing up. Let me do that. Maybe I can, maybe I can't. Okay, not there. Okay, maybe I can't get it quickly. Anyway, it's in an Evo life cycle, and essentially you can see these balls. But when we did the live session, there were these balls, but they were connected by a little spiral sweep up from the other side. And I'm going to show you this now, because I think it's quite interesting. This is on the top of Jupiter, okay? And what you're seeing is there's a big vortex in the middle. Now, we know our ball lightning spins, okay? We know that the ball lightning spins. We know, or at least it looks like, we are making micro ball lightning or macro ball lightning. We have shown in the Vega experiments that the material spins around the anode. If you have like round, kind of like these type of electrodes, it spins around there. And so you've got this spinning around here. You've got a boundary layer here, and then around here you've got it spinning kind of like that. And then you have this material that comes in here, so it's like spinning around there, and it's pulling some stuff off here. And it's spinning around there, and it's pulling some stuff off here. And it's spinning around here, it's pulling some stuff off there, okay? Now, this is like. It can't get too close together, because it kind of pushes itself apart, gain here. So they self-organize around here. So we saw these kind of structures where the exact equivalent of what Shoulders showed in Evo Life Cycle, I think it's in Evo Life Cycle, but like I say, I will clarify on the newsletter at remoteview.icu. There were the balls, and then they had this sweeping material in. So not only was the ball in the center spinning around, something was spinning around the outside of those where the exotic vacuum objects had gone. And what I've done here is I've perspective adjusted it, and I've overlaid this hyperbolic spiral on top. So you can see it comes in here, round to the center, and then this is stripping some material off here. So this is essentially the same thing that I was showing you over the other samples as well. Okay, now I'm going to go back to getting the images of that Henk sent me over yesterday evening. think I'm ready. So this is something that was completely unexpected. Okay. Like I say, all he did was he saw the part of the presentation, the things that I was going to be talking about in the updated blog after I failed to show yesterday. And he thought, oh, I'll go and see if there's anything on my electrodes. And, well, you couldn't make this up. So let me just go here. Here we go. And so it may or may not be clear to you, but like I say, these things don't care whether they are in any particular orientation. And like I say, they're not always perfect, but you have triangles, 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 okay, all over this material. And it's when things have been affected by EVOs, they tend to corrode, okay? So you've got them interacting with each other in different places, okay? So this is the first, and like I say, we want to try and get some better imagery. So you've got, I don't know, it's off shot now. This one, you can't see that. Oh, that's not very good. Here's another shot, and you can see the corrosion on here. So it needs to be better. So I'm not wholly convinced, but they are definitely triangles. And why would things grow in triangles? Here's a different structure, but these are kind of like a fractal triangle conglomerate. So it's like they're coming together, or was it that they were all in a big blob, like they were in a big blob, and there are loads of these monopole type structures that have come together, not only in a bead chain in a kind of a circular structure, but also the bead chains have joined together into a big mesh, a kind of like itonic mesh. And this is the itonic mesh as it kind of fell apart. But if you go into here, these are triangular structures that this is comprised of. It's like it really does look like some sort of fractal structure, and it has this kind of same triangular type of ratio going on. But you know, I'm always a bit skeptical when I see things and immediately report them, because it's not necessarily the best. So this is like the support, and this is the cathode, and as far as I understand it, this is the underside. And so whatever happened, like in the Bogdanovich paper, it actually traveled through. But actually, some of these are even better. But we need a higher resolution on this. But there are a lot of them on here. Okay? A lot. So it's very clear to me. And what's interesting is they're basically all the same size. And moreover, where you can see this area here where the main plasma area was, it's not affected. So these things, as we know, and you'll see in a video that I will share soon, that you can see what I'm calling, there's a ball like a plasmoid, a very large plasmoid. And from the plasmoid, it's spitting out these structures. And it's absolutely beautiful. When you see it, it's going to blow your mind. But I need to do some work on it. But I hope to get that out in the next day or two. But the ball is, we've established that inside the ball there may not be anything going on very much of any interest, and in fact it might be a safe zone in there, although you might have a problem with time and consciousness. But anyway, you can see this curved area here, okay, but outside the ball of fire or the plasmoid's influence, you've got this spray of these structures. This is again for me something it's very concerning. It's very concerning because the volume of production of exotic vacuum objects here is you know, extremely large. It's extremely large, and so we need to focus on safety. So the next couple of weeks I'm going to be focusing on safety, shielding, and detection methods. Yeah, I mean, over here it's like it's just a big triangle grid and it gets less and less towards the boundary layer of where the plasmoid was, and so on. So there we go. Right, now next, yes, it is a component shape that is derived from a hexagon. And if you imagined, if you go back to the, let's quit that, and I go back to the Bogdanovich paper here, he says here, where is it? This stream formed into a set of several rings, 5 or 6, and it's typically 6. We've seen 5 or 6, but I'm saying, and I've said for a long time, that these structures form into allotropes of carbon. And one classic allotrope of carbon is the buckyball, okay? And that has 6 sides and 5-sided polygons on it, okay? So it's not surprising me you see 5 and 6, but typically it's 6, like you see on the Hutchison sample here, this 6-sided structure here, okay? Now, that's not the only thing that I think is quite interesting, and this is unrelated, but it is related. Is it? I don't know. But this will segue into the next couple of presentations that I will do, other than the safety and detection presentations. And that it was, let me see if I can find the comment first. Maybe I can find it up here. Okay. Okay. I'm going to copy a video. It's not my video, but I'm going to copy it into the chat so you can have a look at it. Okay. So there it is. And if you then go and the comment was on the Let's Talk About Reactor Designs. And he said, what do you make of the pattern of holes on this megalithic stone in megalithic Sacsayhuaman? Other people will probably know how better to say that than me. And it's actually an extremely good video. Maybe I can show that. How can I show that? Anyway, you can see the video yourself. But I'm going to show you what I thought when I saw it. And in a introduction to that, I just want to talk about this. I just want to talk about this monopole clutch, and I had this libation disc from Egypt, and it has the card aspect there around the outside and the Ankh, and I established that this is the Perovskikov strange radiation quanta. And it's a 50% section through caught on normal film, black and white film, and that the ratio of the areas here are quite tight, and that this structure of either going in or going out is fades with the change in the depth of the spout on the libation disc. Anyway, and supposedly from the loop down, this symbol, i.e. the symbol of the Ankh, represents the key to all hidden knowledge. Okay, so this part down on the Ankh represents the key to all hidden knowledge. Okay, so that being said, I'm going to go back to the subject in hand. So I saw something immediately when he said, oh, do you see anything in that pattern on these holes? Not in the pattern so much, but I did see something, and this is a bit of fun here. I did see something, and it was this. It was these triangular holes. Okay, and they're pointing in the other direction to gravity. Okay, maybe it's a monopole going in one direction. Now, it might be seeing faces in clouds, whatever, but he asked me to look at this, and I saw this. Okay, and so I thought, well, okay, if this rock was really, this megalithic stone was really melted by this technology, if it was like made liquid by this technology, then, and I am suggesting in my monopole clutch, so I'm saying that this structure is caused by a monopole, and I've demonstrated that, I believe, to you. Okay, there's also this spiral with the tail over here, but anyway, that's a different thing. If this is caused by monopole, then I would imagine that this is relating to the Ankh. So I just thought I'd go and have a look for something to do with the Ankh. Okay, and I found this Ankh symbol here, and it turns out that the Ankh is basically always associated with this triangle. The Ankh is basically also always associated with this particular aspect triangle. Okay, and so I wanted to go and find out, because I want to do those kind of things. I want to give the source of who provided this particular image. So let me go and find that. Be with you in a second. If I'd had a little bit more time, you wouldn't have had these pauses. But anyway, I just want to get it out the door now. Okay. I've lost you. Have I lost you? What happened? I don't quite know what's happened. I've lost the screen. Okay. Right, so it is playing this. I don't know whether you can see what I'm going here. It's not in shot. Maybe I can make this slightly smaller so you can see. Oh, good. You're still there. I'm still here, at least physically. So I don't know whether you can see this, but I'm going to try and shrink it down so that maybe I can zoom in a bit. Oh, why is it doing that? Okay. Okay, that's not going to be very helpful. Okay, well, anyway, hopefully that's in shot. Okay, so I couldn't believe it. The source of this particular presentation, the source of this particular image that I've just showed you here, this particular image, because I have to give the source of where it came from, where we have the Ankh, which I'm saying the bottom part of this is the key to all hidden knowledge, and that this is the structure that creates the monopole, and the monopole leads to these triangular structures that you see in things that have been affected by this technology. So I went here and so I looked for the image. I've not read it, by the way. I just scrolled down. Oh, there's the image. Okay, so it said Sesostris the first offering showbread or shoebread to Ammon in the White Chapel at Karnak. Okay, so I'm just going to say like what it says here. It says what does it say? It doesn't say. Okay. Okay, so here it is again. You've got the Ankh, and it's got this particular triangle associated with. Like, so you've got the triangle here, this triangle, and the Ankh associated with it. You've got the Ankh and the triangle associated with it, and there's a breakdown of the triangle. And again, this is the Ankh and the triangle, and so on. So apparently, this triangle is called the Sothic triangle. I only found this out like a few days ago. The Sothic triangle is generally adjacent to an Ankh as seen below. So it's got an image there. A sonic device shaped like the Ankh, according to an unpublished Seth session. So I don't know. I don't even know who Seth is. But anyway, the point is, sound does play a role in this. The first exotic vacuum objects, the first strange radiation I observed came from the 19.46 kilohertz, 4 kilowatts vibration fuel producer of Suhas Ralkar. And that was producing strange radiation months after its production. This means that this is throwing out strange radiation, which means the active structures in that fuel was working at room temperature and throwing out this material. Okay, so it says here, a sonic device like the Ankh, according to the unpublished session, was used by ancient people to soften stone. To soften stone! I mean, really? That's what it says there. So it could be carved easily. So you could carve the stone. You could make it like a John Hutchison piece of aluminium. You could make it like this jellified aluminium, and then you could bend it and move it around, just as Alec Pizarro did when he went to touch a piece of Hutchison-affected aluminium, and he put his fingers into it and left his fingerprint in the aluminium. Okay? So it could be carved easily. I would imagine that the softened stone would be easier to extract the M state form. So I suppose this is talking about Ormus. The 4:9 ratio, this is just a comment by him, the 4:9 ratio of this Sothic triangle is the reverse of the 5:9 ratio of the weight that Hudson, that's I guess David Hudson, claims remains when metal is converted to M state. 4:9 would be the portion which is no longer physically measurable. These last two observations may not have any scientific validity. They may just be coincidence. Anyway, I'm just saying that we have a... well, can I change cameras now? Okay. Maybe I can. Is that... Okay, back in the room. Okay, so what I'm saying is that I observed these triangles in a range of different systems a number of years ago. I then observed spirals, and I observed these
structures that in my mind could only be formed by magnetotoro structures, toruses that had magnetohydrodynamics. And so, and that they had to be solitons, and they had to have this particular kind of structure. And so what, I see what's going on here. I don't want that. So these magnetotoro hydrodynamic structures with these counter-rotating vortices, they had to have some sort of soliton in them, and I believe that the soliton was able to focus matter into a location, and that this became a magnetic focal point, and that it's not a real monopole, but on the local level it acts like a monopole, and according to Wisniewski, and supported by the Russians at the Russian Nuclear Physics Institute in Moscow, they're saying that this is able to cohere and create Cooper pairs out of electrons, which are normally fermions, but if they're a Cooper pair, they make themselves into a boson, and that these can be focused down into not a infinitesimally small point, it is a fixed point, but that then creates a triangle. So you have superfluidity, you have superconductivity, you have incredible energy in whatever is in that magnetic core. And so I think we might be getting to the bottom of something here. Anyway, I'd be very interested in what you think. I'm going to talk a little bit more about aspects around this. And if you have any comments or you have any criticisms, I'd be very happy to hear it. So I'll just read your comments here. As it so happens, and I've talked about this before, I have some monoatomic gold. In fact, I have 3 different samples from a highly experienced maker in Hungary. And I will be sharing the analysis of this. I haven't analyzed another sample from another party, but it is very fluffy. It's very fluffy, and it is nanoparticles. It's under the microscope you basically can't see the dimension of the particles as far as you go in. And I'm going to talk about how I believe that this material potentially, if it is, I mean, I just literally going through the process that I went through the last few days, it was quite spectacular to see these triangles. Someone say, oh, you know, what about this on the stone rock? And then I go, well, okay, what is associated with the Ankh? And they go, oh, it's this sothic triangle. Oh my God, the sothic triangle is the same aspect as the triangles that we're seeing. And by the way, it could be the core of a or pointing to the hyperbolic spiral focal point of a Wisniewski type Dirac monopole derivation. And that if that's the case, this is something that is able to focus an unimaginable amount of energy and cohere energy. And as I've said, the sound produced fuel for the echo reactor was shoving out strange radiation for a long period of time. Okay, so and we know that according to Shoulders, he says that these things can stay in metals indefinitely. We know from Zatelepin and Baranov, they were able to re-excite their bismuth 18 months after their original experiments by exposing it to sunlight, or at least putting it into the sun, which means maybe it's cohering photons, or maybe the photons are causing electrons to be emitted, and that those are being cohered and then re-exciting the exotic vacuum objects. But this could be technology that is able to extract all kinds of phonon-based and photon-based, or basically any boson. And I've said that in my question answer session in Sochi in 2018. And so you could imagine that if you had a container full of this stuff, that it could be not extracting, but basically harnessing energy. And we've already shown that some of the material that's available for harnessing in the form of cold neutrinos is able to pass directly through solid matter. I'm not interested in neutrinos. I'm interested in cold neutrinos. This is the flux of material that comes through. And you've already seen in the Bogdanovich paper that part of these structures can transmit through dielectric materials. And obviously, if you had quartz in some structure, that quartz would be emitting electrons piezoelectrically. And so there are all kinds of things to consider. But if it is able to cohere energy, it could cohere unimaginable amounts of energy. This here could be an unimaginable amount of energy in my hand right now. And releasing it could do some weird stuff. And maybe that's what happened with David Hudson when he took the electric arc furnace and tried to use the electric arc furnace to make this atomic gold go into something else. I don't know, but we have a lot of correlation. Correlation doesn't make it fact, by the way, and I'm very well aware of that. But I would like to, with that monoatomic gold, try and replicate the Hutchison, not the Hutchison, the David Hudson experiment. But I would like to be a very, very long way away, because as he said, the some form of radiation came out and it caused his glassware on the shelves around the lab to crumble, and plastics. Now, we've already experienced that. If you go and look at my disappearing tungsten, I talk about it, but we know that borosilicate glass is affected by this, and I will talk through reasons why. And we know from the line experiments that fused quartz is affected by this form of radiation. So if you had some structure made out of fused quartz, like, I don't know, made out of granite, and you had this flux of this radiation coming out, there's no reason why it wouldn't fall apart from our experimental evidence. So that's kind of basically it, really, that I wanted to share with you tonight. So it's triangles and spirals. I believe that they are part of this same structure that is a force-free colloidal and toroidal vortex, which creates its own focal point, self-focusing point of matter. It also has the ring. It's got the ring and the spot, which, by the way, is Ra. It's the ring and the spot. And some believe that that is how the sun works. Interesting. Anyway, so the ring and the spot, and this, as I now know, is called the sothic triangle, and it's always associated with the Ankh. So any questions, and I'll probably wrap it up now. It's Alec Pizarro. I will share a link to the description and some pictures of that aluminium that was picked up by him. I think it's Alec Pizarro. No, it's not. It's not Alex. It's Alec, A-L-I-K. I've got it in a blog that I wrote some time ago. Corky, I think if you had yeah, the stone could hold it. I think the problem, if you had metal and you charged it up with this exotic vacuum objects, they would just corrode extremely quickly. They would kind of like degrade they would rust stupid quickly, and they would first turn to like magnetite and then they would rust. But yeah, I mean, we know for a fact from the line reactor that exotic vacuum objects can be made using diamonds and copper and deuterium, and that they can go through dielectric material and go into another dielectric material, into the quartz, and get caught in the quartz, right? And you've actually seen those things blowing up, and quartz changes color when it gets exposed to heat after being exposed to beta particles or X-rays. And Ken Shoulders and the Russians, they all agree that exotic vacuum objects, or whatever they like to call them, can be point sources of beta particles and X-rays. So everything that you see in the experimental data points to the fact that Shoulders was right in what he was saying, and this shows that the EVOs had gone into the quartz. Now, almost all of Earth is made of, or the crust of Earth is made of oxygen and silicon. So, and most rocks are, they contain oxygen, silicon, and aluminium and iron and things. But most of them are oxygen and silicon. And so, if it is in quartz and most granites and a lot of rock, it contains quartz crystals in there of some type. So if you could maybe capture them in there, or capture them in metals that are also in, well, obviously silicons are kind of metal, but you can capture them in the material that's in there. And I've talked about this with the little magnetite grains in basaltic type rocks and the rocks in South America, that you could have the EVOs clustering on those grains. And that then you could probably energize them with bosons in the form of what do you call it? Sound. And on that note, I will be talking about these a little bit next week, but I've already talked about these. The fact that in the 1950s they found that if you took a microwave horn and you had a quartz crystal and you put the microwave horn there, the piezoelectric crystal would convert that into a phonon, a soliton of the frequency of the microwave, and it would travel down the quartz rod and come back and give out chirps based on the speed of sound in the quartz. And so you get chirps of the microwave light coming out based on the length of the quartz crystal. So what that is telling you is that it's a transducer. It's a transducer for, and we know this, we know it is, but normally you put pressure onto a quartz crystal and you get electrons out. But in this case, you put light on it, and you get sound that then converts itself back into light. Okay, so if you had a quartz-rich rock and you had exotic vacuum objects clustered around magnetite structures within the quartz matrix, then the quartz could convert sound into both electrons, emitted electrons, and also into light, but light at a frequency corresponding to the sound. You get me? And so sound or light may be able to recharge the exotic vacuum objects in there, but you need to create the exotic vacuum objects that are dense enough to start with. That's what I have to say about quartz and rock. I will, like I say, I'll talk about these. As I've already said that I'm going to put these in the supernova reactor. I've sent some to Henk to put in his reactor.
It's interesting you mentioned Thoth. Anyway, I'll leave it there. Okay. Yeah, I mean, the reality is that it would seem that all of this technology the Egyptians could do. And in fact, in 2006, Ken Shoulders said precisely that. And on a different note, John Hutchison's one of his companies with one of his partners in the past was called Pharaoh's Technology. And also Norris Peary, his company was called well, his company was had a symbol, an Egyptian symbol. So I don't think this is something that I'm being original in realizing. And in fact, I'm certain I'm not. Yeah, quartz can make light because firstly you can have spark, but yeah, you can if you stress quartz, you can make light. Yeah. And so if you have things that are, as I'm bending this quartz, or I'm putting it under pressure, there will be photons coming out of there. You know, very low frequency photons. And it is interesting when I do John's book, you will probably see that sometimes very, very low frequencies of light are used. And I don't think it's any coincidence that the woodpecker was such a low frequency. Hi, FB Angel. Okay, so I'm about done, really. Head over to remoteview.icu. Put any questions you've got down there. Like I say, I will fill out the article with some images and other stuff. The pictures of the bluestone axes used to work the 2+ ton stones. I'll have to take your word for it. I don't know what you're talking about. Right, okay. I didn't know that the Ankh was a diode. No, but if it's there's no when you actually look at the structure, the vortex structure with the cone going into it and the sort of infinity area, that focusing, it is effectively rectifying energy. In terms of it's like a capacitor as well. It's a self-contained capacitor for rectifying and harnessing energy from the environment. I'm sure there are people that watch this stream and go, no! Bob, you mentioned someone a few shows ago about oxygen and water. I've talked about that in this presentation. Also, it's Leonid Oroitskia, and I can't remember which. I talked about it in my Russian presentation, the cold nuclear transmutation of ball lightning presentation on the monopole clutch. And if you go to the monopole clutch, there is a PDF in the description and the link to the 2006 paper by Oroitskia and et al. Talking about the explosion at Chernobyl. I'll address that separately, but essentially, if you consider that SV Adamenko was using 1 to 300 joule discharges and produced 1,000 times more energy out, but he also observed strange radiation tracks, and you can go and look at the papers by him with Vladimir Vysotsky. So we know that that was producing strange radiation. What happened was the turbine was
decoupled or something, and he argues in the paper that this would have caused a kind of build up back EMF or whatever, a discharge. But if you calculate the amount of energy in that discharge, it's many, many, many orders of magnitude more than SV Adamenko was using in his Proton 21 labs. And the idea that he has, and I'm quite supportive of it, it is that this produced a vast flux of monopoles, exotic vacuum objects, and that they went into the water. And I will talk about why after I've dealt with the safety concerns. But this really speaks to many of the so-called alternative energy technologies that have been discovered since probably the beginning of the last century. Water plays an incredibly important role in certain versions of these technologies. Okay. So yeah, the links in the presentation, and the link to the presentation is in the monopole clutch video. So, Axel, you're talking about the anti-gravity activity of the EVO. I can say that the presentation that I talked about, and I gave a link to earlier on in this presentation, and it will be in the newsletter. It was from the two Russians, Baranov and Zatelepin, but he was talking about the mass of spinning objects, and he was basically saying that if you spin in a certain orientation, you will get a anti-gravity kind of effect. And obviously, when you're not having to physically rotate these things, it's doing it itself by the nature of what it does. You don't have to have a physical mechanism spinning something around, and because it contains itself, it doesn't fly outwards. It has its own confinement that it can spin extremely high velocities. And I think he was quoting that natural ball lightning is spinning at like 100,000 kilometers per second. I don't know if that's even real, but you can go and look in the video for his presentation. It's on the mass of spinning objects or something like that from Sochi 2018. You can, in the video description, there's a link to the paper which you can go and look at. Yeah, I don't know whether TP Sven, I don't know whether it is the golden ratio. Maybe someone could do the maths, but if you look at that sothic triangle and you do a hyperbolic spiral based on the sothic triangle, does that lead to the golden ratio? Maybe, I don't know. Could it be that the pitch of that triangle changes depending on the material it's in? Depending on the level of excitation, I don't know, but I do tend to see this particular aspect of triangle, although it is softer depending on the, as I said earlier in the presentation, the melting point, the electrical conductivity status of the material that is under question, and the strength at which the interaction between either the lattice or the chemical bonds is. Okay, so I think I'm going to have my late dinner. So I thank you for your time, guys. And I'm trying to improve these presentations, and it is better to have slides, yes, which means more work, but still there's some holes. Hi, Taryn. Okay, so I'm going to say goodbye now. And yeah, any questions, throw them really into remoteview.icu. Remember the light bulbs above and below the galactic plane. Okay. So yeah, and you'll have all the images. Actually, many of the images you've already had. I think it's very interesting, the comparison between the Evo interaction with a layer in the work of Shoulders and the recent work of the the Vega Valley. As above, so below. Yes, it is. Yes. Yin yang. Yeah, okay, a good point on the overexposure, but actually what I want to do is try and make a NewTek direct interface or NDI link, and so I can actually just show the slides with the animation without it being through a camera. Okay, so bye now. I really am going. Bye.